On a clear night, the sky looks changeless. It is an illusion. We are too short-lived to see it move. These are photographs, real galaxies held still, and every one of them is being pulled apart. A streamer of stars longer than the galaxy that shed it. They call this one the tadpole. Astronomers could not account for these shapes and went looking for something violent enough to explain them. Magnetic fields, explosions, matter thrown from the centers of galaxies. A few had guessed at gravity, but guessing is not knowing. To find out, we have to build a galaxy of our own. This is not a photograph. It is a galaxy made inside a computer out of nothing but gravity and 150,000 points of light. Most of its mass cannot be seen. We call that dark matter for want of a better name. Left alone, it turns, the middle going round in 100 million years, the edge taking 4 times as long. And look at the arms. Nobody drew those in. They grew out of the disk pulling on itself. But nothing a galaxy does alone will tear it into threads. For that, something has to arrive. And here it comes. Another galaxy much the same size, falling in along a long curve. They will not crash, they will pass. The near side of each is pulled harder than the middle, and the far side less. That difference is a tide, and it is enough. These stars are already turning with the pull, so it stays with them, drawing them out and away. That is a tidal tail. The arch of stars between the two is a bridge. Not one star has touched another. None of this is our idea. 2 brothers, Allah and Toomre Toomre, settled it in 1972. Their first attempt used 120 points of light in 5 thin rings, feeling nothing but the pull of the 2 galaxies. Out came the bridges. Out came the tails. But a picture that looks right is not evidence. So here is the one that ought to fail. The same galaxies, the same orbit, the same pass. One thing changed. These disks turn against the pull. Now those stars meet it head-on and are past it before it can take hold. Turning with the pull, a galaxy throws 15% of its disk beyond its own edge. Turning against it, 2.5%. An explosion would not have cared which way it was spinning. Gravity, then. But the sky holds far stranger shapes than these. The same 2 again on a closer pass. The same tide, delivered harder and faster, and the tails come away longer, straighter, thinner. And there is a pair in the sky that looks much like it. They are called the mice. Now tilt the disks steeply, and the tails climb away above and below the path they take. This pair is called the Antennae, and yet most of those stars are not gone. They are still bound on long, slow orbits that will bring them home. You are watching a single pass. The encounter itself will run for 1,000 million years and more. Whose stars are those? Here, each is colored by the galaxy it was born in. The two tails stay apart. Each galaxy throws out its own, except along the bridge. There, a few are crossing over, and some will end their lives going round a galaxy they were not born in. Here is a different arrangement entirely. This time the companion does not pass by. It goes straight through the middle, small and dense enough to deliver its pull all at once. Still nothing touches. But now the pull comes from all round, so nothing is drawn out to one side. Instead, the disk rings like a struck bell. The stars keep to their own paths, but they crowd together, and it is the crowding that travels outward. The Cartwheel Galaxy was made something like this. The strangest shape in the sky. The same rule made it. These are the spectacular ones. Most of the universe is not spectacular. Most galaxies never meet an equal. They feed instead on companions far smaller than themselves, pulling them to pieces a little at a time, and taking, in return, a slight and permanent warp. Our own galaxy is doing it now. But when two equals do meet, sometimes neither gets away. Each one, moving through the other's halo of dark matter, gathers a wake of it behind, and that wake pulls back on the galaxy that raised it. Every pass costs them a little speed. The orbit tightens. After 1,100 million years, the two centers are closer together than either galaxy is wide. Two spirals went in. Look at what comes out. These stars once moved together all one way. They are turning but no longer together. A spiral is a disk, and a disk has an edge. This has none. Brightest at the middle, then fading on and on, further out than you can follow it. There are galaxies like this in every direction. We call them ellipticals. This one is not quite there yet, but it is on its way, and this is one of the ways we think they are made. And so back to the mice. Here they are again, with a simulation laid over the photograph. Two galaxies of much the same size, caught a little after their closest pass. The shapes agree, and agreement is not proof. A great many encounters could make a shape like this one. Which of them actually did? At what angle and how long ago? We cannot yet say. One day we will. There is a pair a good deal closer to home. The Milky Way has a large neighbor, Andromeda, and the two are closing at 110 kilometers a second. For a long time, the answer looked settled. They would meet in about 4 billion years and merge a couple of billion years after that. Then the measurements grew sharper, and the answer came apart. It all turns on how fast Andromeda is drifting sideways, and that we cannot yet measure well enough to say. A merger still looks likely. But likely is not certain, and certain is what we thought we had. Every pair of galaxies caught like this is one frame of a film too slow for us to watch. We could not wait for the rest. So we built it out of gravity and time.